Good afternoon. Good afternoon to all. It is hearable. Hello. Hello, it is audible.
Yes, sir.
Thank you. Okay. Yesterday class we discussed about some of the components of the node architecture of the wireless sensor network. That means microcontroller and communication device. And in communication device means transceiver, the characteristics, and sensor and accumulator. And also we discuss about the power supply. What are the different types of power supplies that will be present on the sensor network? Okay. Now I want to discuss about the energy consumption of the sensor nodes. This is also a very important topic. How much of energy that will be consumed by the component of that particular sensor node. Okay. So here in so far previous sections only we discussed the what are the primary batteries, what are the secondary batteries that will be types of the energy scavengers, what are the rechargeable batteries that will be supported for the wireless sensor network. Here coming to the energy consumption of the sensor node must be very tightly controlled by the how much of energy that will be gathered how much of energy that will be consumed according to their application task, according to the what type of material used for the wireless sensor network, and how much of energy efficiency it will be in the wireless sensor network that will be reduces the functionality of the multiple states of the operation with reduced energy consumption. Based on the energy consumption only, whatever the high level task, whatever the application task that will be function. Okay, so here you can see some of the all the components of the sensor node energy consumptions with some examples. So first, the major energy consumption of the wireless sensor node architecture is microcontroller. So microcontroller is the major energy consumption of that particular wireless sensor node. Okay, so here for a controller, typical states are active, ideal, and sleep. So whenever you choose the microcontroller, only we have three types of states, which is considered as active state, ideal state, and sleep state. So the radio modem, which should be turned into transmitter and receiver and both on or off state of the representation. So at T1, you can see the diagram. At T1, the microcontroller is put into the sleep mode, should be taken into the reduces the power supply from P active to the P sleep. So here you can see P active to the P sleep at T1, it will be reduces the power consumption of that particular level. So it is the sleep mode. Okay. If it is remains active and next event occurs at the T event. So this is the T event. It is active whenever the T event will be obtained next event. Okay. And this is the T down. That means until the sleep mode has been reaches, the average power consumption during this phase is P active plus P sleep by 2. So P sleep is consumes until T event. The energy saving is given by E saving is equal to T event minus T1 P active minus T down into P active plus P sleep by 2 plus P event minus T1 minus T down into P sleep. So first part is the second unit ni add chestunam P sleep P active. Third part వచ్చేసరికి P event లో నుంచి minus T1 ను T down అనేది తీసేస్తున్నాం. This is the E saving. And also we have the overloading of that particular event. So that cases P overload is equal to T up into P active plus P sleep by 2. That is the formula for particular E event. Okay, switching to the sleep mode is only beneficial if E overload very less than E saving. So when switching to the sleep mode kind of consideration తీసుకుంటే always E overload will be always less than E sleep. That is the condition for that particular representation. Okay, this is the microcontroller. So microcontroller we have only 3 modes: sleep mode, idle mode, and active mode. Idle mode means there is no energy will not be consumed. Okay, active mode only energy will be consumed, and sleep mode total energy will be reduces. So here transmitter and receiver both on or off will be considered. Whenever you choose the T1, that means P active to P sleep, then automatically the total energy will be reduces here across the T sleep. Okay, so this is the T sleep. Power active and power down will be takes place like this. Okay, some of the examples were related to the microcontroller. We already know the microcontrollers that will be used for the wireless sensor networks: Intel Strong Arm, Texas Instrumentation MSP430, Atmel 80 mega. So these are the main chip designing companies that will be designs the microcontrollers. Okay, first one we can see how much of power that will be consumed by the Intel Strong Arm processor. Here Intel Strong Arm processor, which will be provides the 3 sleep modes. One is the in normal mode, all ports of the processors are fully powered and power consumed is up to 400 milliwatts. Okay, normal mode means all the parts of the consumer microcontroller which will be fully powered and power consumption is 400 milliwatts. In idle mode, the clocks to be CPU are stopped and clocks that pertain to peripherals are active. Okay, only idle mode means it is stopped in position and only peripherals are active. Any interrupted will be obtained in that case, so it will be automatically it will be returned to the normal mode, then the power consumption up to 100 milliwatts. Okay, whenever any interrupted that will be obtained across the microcontroller, immediately it will be comes to the idle mode to the normal mode, then the power consumption is 100 milliwatts. A sleep mode, only a real-time clock remains active. Wake up occurs when the timer interrupted and takes place 160 milliseconds. The power consumption is 50 microseconds. Sleep mode means totally the system will be in the sleep mode that doesn't need any power consumption. So whenever the waker occurs, any interrupted timer will be given, then within the 60 microseconds the the power consumption is 50 microwatts, very low. Okay, this is the Intel Strong Arm processor microcontroller. Sorry, Texas Instrument MSP430. This is the one of the microcontroller. This is MSP430 family. Wider range of operations will be takes place here. One fully operational mode which consumes 1.2 milliwatts. 1.2 milliwatts. Okay, and there is a 4 sleep modes in total. Deepest sleep mode LPM4 only consumes the 0.3 microwatts, but the controller is only wake up when of the external interrupted in this mode. Okay, we have 4 sleep modes in the Texas Instruments. So one is deepest sleep mode LPM4 only consumes 0.3 micrometers. It will be interrupted wake up by the external interrupted in this mode. The next higher mode is LPM3. The clock also be till runs when which can be used to schedule wake ups. Okay, schedule wake ups everything considerations తీసుకుంటాము. That is the higher mode of that particular deepest sleep mode. Still consumes 6 microwatts. And Atmel which is considered as a 6 different modes of the power consumptions. It is similar to the MSP 430. The principle is same, but differs in some details. The power consumptions will be vary 6 milliwatts to 15 milliwatts in ideal and active modes. Okay, ideal mode lo 6 milliwatts అనేది ఉంటుంది. Active mode loki వచ్చేసి 15 milliwatts అనేది యూస్ చేస్తున్నాం. And also 75 microwatts power down modes అనేవి యూస్ చేస్తాం Atmega లో. In that also 75 microwatts will be utilized. And coming to the memory energy consumption, these are the microcontroller power consumptions. Whatever the sleep modes will be initiated whenever you are explaining, they will be consider some examples. In that also how much of power that will be consumed we are discussing here. Okay, so coming to the memory energy consumption, here memory energy consumption, it is also a very important on chip memory and flash memories. Only off chip RAM memory will be used rarely. Okay, the power needed to drive a chip memory is usually includes the power consumption numbers given by the controller. So already we seen in the node architecture, the memory will be connected to the microcontroller. So here also the power consumption numbers that will be given by the microcontroller only. Okay, the most relevant is flash memory. In this construction, usage of the flash memory is heavily influence node lifetime. So whenever flash memory, that will be also be influence the lifetime of that particular sensor node. Okay, read and write and energy consumption will be also be takes place. So whenever the read times and read energy consumption tends to similar to the different types of flash memories. So here energy consumption needed to reading and writing to the flash memory is used to the mica nodes. Mica nodes are small nodes, we can see later. Okay, this is a one type of sensor mica. Okay, and here flash memory కి వచ్చేసరికి ఏంటంటే రీడ్ అండ్ రైట్ ఆపరేషన్స్ తీసుకునేటప్పుడే ఎనర్జీ కన్జంప్షన్స్ అనేది టేక్స్ ప్లేస్ అనేది తీసుకుంటుంది. ఓకేనా, రైటింగ్ టు ద ఫ్లాష్ మెమరీ కెన్ బి టైమ్ అండ్ ఎనర్జీ కన్జంప్షన్ టాస్క్ దట్ విల్ బి బెస్ట్ అవాయిడెడ్ బై ద యాజ్ మచ్ ఆఫ్ పాసిబుల్. ఓకే, ఎక్కువ అవాయిడ్ చేయడానికి ఛాన్సెస్ అనేది తీసుకుంటాం ఫ్లాష్ మెమరీ చూసుకునేటప్పుడు. ఓకేనా, దీస్ ఆర్ ద memory energy consumption. Okay, that will be depends on the number of consumption number that will be given by the controller only flash memory that will be consumes the energy whenever it will be writes and reads only. Okay, that is the main important of that particular memory energy consumption. And coming to the communication, so communication వచ్చేసరికి radio transceiver energy consumption. Radio transceiver energy consumption. So radio transceiver have essentially two tasks. One is transmitting and receiving data between a pair of nodes similar to the microcontrollers. And radio receiver can operate different modes. The simplest one that been turned to the turn on or turn off. Okay, simplest one is turn on or to turn off. Only for the transmitting transceiver will be on or off. That based on that particular representation. To accommodate the necessary low total energy consumption, the transceiver should be turned off most of the time. Only the activated when it is necessary. They work to the low duty cycles. Okay, transceiver అనేది ఎక్కువగా మనకి low టర్న్ ఆఫ్ కండిషన్ లోనే మనం ఎక్కువగా కన్సిడరేషన్స్ తీసుకుంటాం. ఎప్పుడైతే నెసెసరీ టాస్క్ అనేది ఇంప్లిమెంటేషన్ కి వస్తుందో దెన్ ఓన్లీ దే విల్ బి కమ్స్ టు ద low duty cycles అనేది కన్సిడరేషన్ యాక్టివ్ పొజిషన్ లోకి వస్తుంది. ఓకే, the energy consumption of the transistor due to the two sources. One is due to the RF signal generation and which mostly depends on the modulation and target distance. Second part is electrical component necessary for frequency synthesis and frequency conversion, filters, so on. మనకి ట్రాన్స్రిసీవర్ లో ఫ్రంట్ ఎండ్ టు బ్యాక్ ఎండ్ చూసాం. So there is will be using the amplifiers and low bias amplifiers and oscillators and intermediate frequencies. For that purpose only the energy consumption will be takes place. Okay, RF signal generations దగ్గర మనకి energy consumption అవుతుంది. That will be depends on the modulation and target distance. And second part లోకి వచ్చేసరికి electrical component మన oscillators అనేది యూజ్ చేసాం, అలానే frequency conversions అనేది యూజ్ చేసాం. There the energy will be consumed. So always it will be depends on the architecture that will be sensor network. Okay, this is the equations that will be related to the how much of power that will be consumed by the transmission and how much of power that will be consumed by the receiver. Okay, one is transmitting equation and second one is receiving equation. So coming to the power consumption of the sensor and accumulator. Power consumption of the sensor and accumulator. Providing so coming to the power consumption of the sensor and accumulator, providing and guidelines about the power consumption of the actual sensor and accumulator impossible. Exactly how much of power that will be consumed by the sensor we can't identify. Okay, because of wide varieties of their devices, different types of devices will be used. Small tiny particles, they will be consumed very low power efficiency, and small light some big sensors will be also be consumed more light. Okay, for example, here they will be given some example. Passive light or temperature sensors, the power consumption can possibly be ignored in comparison to the other devices of the wireless nodes. So power consumption అనేది temperature devices లో almost negligible అనేది consideration తీసుకుంటాం, and అలానే passive lights లో కూడా మనం consideration తీసుకుంటాం. For others, active devices like sonar. Okay, active devices like sonar. So a measuring instrument that sends out of the acoustic pulse and sound pulses are consideration in water and measure distance in terms of the time for the echo of the pulse to return. So power consumption can be quite considerable in the dimensions of the power source in the sensor node. So depends on the application will be decided the power consumption of the sensor and accumulator. Okay, so coming to the operating system and execution environment. Coming to the operating system and execution environment. So మనకి ఆల్రెడీ మనం డిస్కస్ చేసాం, ఆపరేటింగ్ సిస్టమ్ అనేది రియల్ టైమ్ ఆపరేటింగ్ సిస్టమ్ ఉంటుంది that will be supported to the hardware and that will be functioned by the medium axis controls. Okay, we want to run the operating system, they will need some operating system. Okay, embedded operating system అనేది యూస్ చేస్తున్నాం. ఇక్కడ చూడండి, యూజర్, అప్లికేషన్, ఆపరేటింగ్ సిస్టమ్, హార్డ్వేర్. ఫ్రమ్ ద హార్డ్వేర్ operating system, application, user. This is the operating system of the sensor network. It is a cyclic. Okay, and coming to the operating system, it will be system software that manages the computer hardware and software resources and provide the common services for the computer program. So here always we will be provide the software for the managing the hardware and software, and also you can manage the resources that will be allocated for particular communication services. Okay, so hardware functions are such that input, output, memory allocation, and operating system acts as a intermediate between the program and computer. Okay na, operating system అనేది ఏవైతే ఇన్పుట్స్ ఇస్తున్నారో, ఏవైతే అవుట్పుట్ ఇస్తున్నారో, మెమరీ అలోకేషన్ ఏదైతే ఇస్తున్నారో, అలానే it will be operated as a intermediate between the hardware and ప్రోగ్రామింగ్. ఏదైతే ప్రోగ్రామ్ అనేది మీరు టైప్ చేస్తున్నారో హార్డ్వేర్ కి మీరు లింక్ చేసుకోవాలి. ఓకేనా, సో ఎంబెడెడ్ సిస్టమ్ ఇస్ సమ్ కాంబినేషన్ ఆఫ్ ది కంప్యూటర్ హార్డ్వేర్ అండ్ సాఫ్ట్వేర్ అండ్ ఫిక్స్డ్ విత్ ఏ క్యాపబిలిటీ ఆర్ ప్రోగ్రామర్ అండ్ స్పెసిఫైడ్ డిజైన్ ఆఫ్ ది పర్టికులర్ ఫంక్షన్. సో ప్రోగ్రామింగ్ అనేది ఇంపార్టెంట్ ఇక్కడ రెండింటికి. ఓకేనా, అండ్ ఎంబెడెడ్ ఆపరేటింగ్ సిస్టమ్ ఇస్ డిజైన్ యూజ్డ్ టు ఎంబెడెడ్ కంప్యూటర్ సిస్టమ్స్. సో ఏదైతే సాఫ్ట్వేర్ అనేది మీరు డెవలప్ చేస్తున్నారో that will be always be supported for the embedded computer system, and it will be operated limited number of services. Okay na, resources అనేది చాలా లిమిటెడ్ అనేది యూజ్ చేస్తున్నాం. ఓకే నా, and extremely efficient whenever you are designing the embedded operating system for the sensors. Okay, here first operating system that now not only fast, it is a very suitable for the wireless sensor network is TinyOS. TinyOS is the embedded operating system software which is very suitable for the wireless sensor network. Okay, coming to the TinyOS is a open source and flexible and application specific operating system for wireless sensor network. That means open source means anyone, any type of technology it will be supported, and it is flexible to the hardware and software and application specific operating system will be supported for the sensor networks. So coming to the wireless sensor network consists of large number of tiny and low power nodes. Small node sensor nodes అనేది ఉంటాయి wireless sensor networks. Each of will be executed simultaneously and reactivate program that must work with a strict memory and power constraints. Okay, ఏదైతే మీకు small particles అనేది ఉంటాయో sensors అనేది they will be stimulated at a time. Simultaneously it will be simultaneously and reactivate the program and memory and powers. దేని మీద డిపెండ్ అవుతాయి అంటే మెమరీ మీద పవర్ కన్స్టెంట్స్ మీద కన్సిడరేషన్స్ అనేది తీసుకుంటాయి. సో tiny OS also be have a challenges. It becomes the platform choose for the sensor network that is limited sources and low power consumption. So they will be maintained the whenever you are going to write the program, they always be challenges, limited resources and low power consumption, low power operations. The tiny OS is successfully function. So silent features of the tiny OS, which is simply event based concurrent model and split phased operations that will be developed phases techniques when writing application code. Okay na, ante manaki tiny OS oka silent features ki vachesariki endante స్ప్లిట్ ఫేస్ ఆపరేషన్స్ అనేది సపోర్ట్ చేస్తుంది, అలానే ఈవెంట్ బేస్ అనేది కన్సిడరేషన్ తీసుకుంటున్నాం అండ్ ఇన్ఫ్లుయెన్స్ ది డెవలప్మెంట్ ఫేసెస్ ఆఫ్ ది టెక్నిక్ రైటింగ్ అప్లికేషన్ కోడ్. ఈజీగా అప్లికేషన్ మనకు రిక్వైర్మెంట్ ఆఫ్ ది అప్లికేషన్ బేస్ చేసుకొని ప్రోగ్రామ్ కోడ్ అనేది రాయడానికి ఛాన్సెస్ అనేది ఉంటుంది. It has a component based architecture which provides the rapid innovation and implementation while reducing the code size. మన ఆటోమేటిక్ కంటిన్యూస్ గా కోడ్ సైజ్ అనేది రెడ్యూస్ చేయడానికి న్యూ టైప్ ఆఫ్ టెక్నాలజీస్ ని సపోర్ట్ చేయడానికి ఇట్ విల్ బి సపోర్టెడ్. ఓకేనా, సో నెట్వర్క్ ప్రోటోకాల్స్, డిస్ట్రిబ్యూటెడ్ సర్వీసెస్, సెన్సార్ డ్రైవ్స్, డేటా అక్విజిషన్ టూల్స్ ఆల్ విల్ బి సపోర్టెడ్ ఫర్ ద tiny OS. So tiny OS is easy to communicate with the physical world interfaces. Okay, physical world interfaces లో ఈజీగా కన్వర్ట్ అవ్వడానికి యూజ్ చేస్తున్నారు. ఓకే, whatever the program you are applicated here, concurrent programming and process based concurrent, how process based, how event based programming, this will be used. Okay na, ఈ మొత్తం దీని కిందకి వస్తుంది. Okay na, so first I will be tell about the two process. Okay, first one is concurrent programming. Okay, programming application programming interfaces అనేది ఇక్కడ ఇంపార్టెంట్ ఇది. So congruent process is a computing model in which multiple process execute instructions simultaneously for better performance. So multiple functions anedi, multiple tasks anedi at a time they will be function. At a time they will be function for a better performance. They also be give the better performance. So it means sometimes that happens in the same time as something else. Tasks are broken down into the subtasks that are assigned to the separate process to perform simultaneously. So how it will be simultaneously function means some task will be divided into the subtasks and they will be function assigned separately. Okay now, instead of sequentially they will be carried out a single process. Concurrent process is sometimes said to be a simultaneously with parallel processing. Simultaneously parallel processing, whatever the task that will be given, they will be simultaneously parallel processing will be takes place. And process based concurrent, most modern general purpose operating system support for the concurrent execution of the multiple process of the single CPU. Okay, single CPU use cheskoni lot of multiple operations ni, parallel operations ni use cheskochu. Okay, using the process you are forced to deal with the communication through the messages which is the end log, that means traffic intensity of the telephone system way to doing the communication. Okay, parallel processing అనేది మనం ఎగ్జాంపుల్ కింద టెలిఫోన్ నెట్వర్కింగ్ అనేది యూస్ చేస్తున్నాం ఇక్కడ. Okay, data is not shared, so there is a no risk for the data corruption. Okay, this is also be one of the advantage for the process based concurrent. Data is not shared, so there is a no risk of data. Fault tolerance and scalability is main advantage of this process versus threads. Okay, another advantage of this process is they cannot crash. You are perfectly okay with that, restart them. Okay, networking accessing అనేది ఎక్కడ క్రాష్ అనేది ఉండదు, క్రాష్ కానీ క్రాస్ కానీ ఎక్కడ ఉండదు. So this is the main important of that particular networking. Okay, here you can see in the diagram. In the diagram, you can see handle sensor processor, handle packet processor. So whenever you're transmitting the data from one node to another node, there is a no overlapping of the process will be takes place. Okay, one by one, parallelly they will be transmitted. Here one operation, here one operation. Okay, event-based programming. So event-based programming is totally different from the other type of programming. In computer programmed event-driven program is a programming which flow of the program written by the event using mouse click, key process, sensor outputs, message from the other program. Event driven program will be dominant program used for the graphical using interface. Okay, totally different operations అనేది జరుగుతుంది ఐడియల్ పొజిషన్ లో. at a time you will be sensor event handling అనేది జరుగుతుంది, సెన్సార్ ఈవెంట్ అనేది తీసుకుంటుంది, రేడియో ఈవెంట్స్ అనేది కన్సిడరేషన్ తీసుకుంటుంది. లైక్ దట్ దే విల్ బి ఎసెన్షియల్లీ wait for the event that will be happen and the event technically available of the data from the sensor. Okay, one by one operations అనేది ఇక్కడ జరుగుతుంది. ఓకేనా. Interfaces to the operating system. You must be interface the operating system with the hardware component, and you must be interface with the operations between the application programming interface. Hardware to interrupt avali, at the same time you will be interrupted with the application based programming. That means a set of commands and functions and protocols and objects out of the program that will be created by the software that will be interact with the external system. The external system means hardware, sensors and accumulators and transceivers. So interface between the operating system and వచ్చేసరికి ఏంటంటే మీరు ఏదైతే ప్రోగ్రామ్ అనేది టైప్ చేస్తున్నారో that program will be utilized by the application oriented and that will be supported for the hardware, external hardware devices. Okay, that is the important for the interface of the operating system. And coming to the structure of the operating system and protocol stack. Structure of the operating system and protocol stack. This is also be embedded operating system only. This is also be linked to the embedded operating system. The traditional approach, the communication protocol structured is using layering. Individual protocols are stacked on the top of the each other. So each layer only using functions of the layer directly in traditional approach. Okay, these layers approaches as a great benefit to keeping the entire protocol stack manipulatable in containing a complexity, in promoting modularity and reuse. For wireless sensor network, it is not clear where strictly layered approach will serve. Okay, compulsory ga ade layer approach anedi tiskoval anedi undadu. Okay, always they will be supported. The a protocol stack refers to the group of protocols that are running concurrently. They are employed in the implementation of network protocol suite. It will be depends on the networking protocol surrounded by the nodes, surrounding by the sensor nodes. So the protocol in a stack determines the interconnectivity rules for the layer network model using OSI or TCP/IP models. So TCP/IP models kani లేకపోతే OSI models kani use చేసుకోవచ్చు wireless sensor networks వచ్చేసరికి compared to the traditional. Okay, dynamic energy and power management. సో పవర్ మేనేజ్మెంట్ అంటే ఆల్రెడీ మీకు తెలుసు ఎంత పవర్ అనేది మనం మేనేజ్ చేస్తున్నాం. ఆఫ్ ది కాంపోనెంట్స్ అవ్వచ్చు, సాఫ్ట్వేర్ రన్నింగ్ అవ్వచ్చు, ఆపరేటింగ్ సిస్టమ్స్ లో ఒక్కోసారి ప్రోగ్రామింగ్ అనేది ని బేస్ చేసుకొని కూడా యూ విల్ బి పవర్ management will be also be considered. So dynamic power management is on the system level, it is a problem on the hand. So always you will be time required for the transmission of the component between two states. The factors are negligible, clearly optimized to the always. Immediately you go to the mode, the lowest power consumption possible. So మన power consumptions అనేది individual components కింద కన్సిడరేషన్ తీసుకున్నాం కాబట్టి so far all the system wise వచ్చేసరికి ఏంటంటే మన performance of the scaling down frequency and supply voltage and selected particular modulation coding permitted ఇవన్నీ considerations involvement of the energy efficiency లో తీసుకుంటాం. ఓకేనా. This is the major representation of the embedded operating system. Embedded operating system అనేది ఇస్తే మనకి ప్రోగ్రామింగ్ ట్రేడింగ్ పర్డింగ్స్ అండ్ అప్లికేషన్ ప్రోగ్రామింగ్ ఇంటర్ఫరెన్స్ లో మనకి ఆపరేటింగ్ సిస్టమ్ అండ్ ఎగ్జిక్యూషన్ ఎన్వైరన్మెంట్ అని వస్తే ఇది కన్సిడరేషన్ తీసుకుంటాం. ఆపరేటింగ్ సిస్టమ్స్ గురించి చెప్తాం, అందులో tiny OS అనేది ఎక్కువగా యూస్ చేస్తాం. వన్ ఆఫ్ ది ఎగ్జాంపుల్ ఫర్ tiny OS. అండ్ ప్రోగ్రామింగ్స్ కి అప్లికేషన్ ప్రోగ్రామింగ్ లో ఇవన్నీ వస్తాయి. కాంగ్రెంట్ ప్రాసెసింగ్, ప్రాసెస్ బేస్డ్ కాంగ్రెంట్, ఈవెంట్ బేస్డ్ ప్రోగ్రామింగ్ అండ్ ఇంటర్ఫేస్ టు ద ఆపరేటింగ్ సిస్టమ్, ఇవి మీకు ప్రోగ్రామింగ్ లో వస్తాయి. స్ట్రక్చర్ ఆఫ్ ది ఆపరేటింగ్ సిస్టమ్ అండ్ ప్రోటోకాల్ స్టాక్ అనేది మళ్ళీ ఎంబెడెడ్ లోకి వెళ్ళిపోతుంది. ఎంబెడెడ్ లో ఈ పాయింట్ అనేది యాడ్ చేస్తాం. అలాగే డైనమిక్ ఎనర్జీ అండ్ పవర్ మేనేజ్మెంట్, okay, DPM, dynamic energy and power management is also be very important. These are the basic representation of the system. Okay, next class we discuss about the network architecture and sensor network architectures. Okay, so far we discussed the single node architecture, that means basic block diagram of the wireless sensor network. Wireless sensor network ka main block diagram ni leda నోడ్ ఆర్కిటెక్చర్ అంటాం. సెన్సార్ నోడ్ ఆర్కిటెక్చర్ అన్నా కూడా ఒకటే. నెట్వర్క్ ఆర్కిటెక్చర్ అనేది టోటల్లీ డిఫరెంట్. నెట్వర్కింగ్ మీన్స్ ఆల్రెడీ వి డిస్కస్డ్ ద నెట్వర్కింగ్ మీన్స్ యూ వాంట్ టు ఫైండ్ అవుట్ ది పాత్. మనం పాత్ అనేది నైబరింగ్ నోడ్స్ కి ఐడెంటిఫికేషన్ అనేది రావాలి. సో సెన్సార్ నోడ్ ఆర్కిటెక్చర్స్ కి వచ్చేసరికి ఏంటంటే totally different from the node architecture. Okay, now networking architecture is totally different from the node architecture. We have three types of networking architecture: how it will be communicated with the out of the world, and how it will be communicated with the neighboring nodes, how it will be have the basic merits and goals of that particular network. Okay, we discussed in the next class, tomorrow class. Okay, all of you understand? Hello.